Hello, everybody. Welcome back to the second video on visualization in Seaborn. If you haven't watched the first video, I highly recommend to go back and watch the first video prior to continuing on this video. So in this video, we're just going to do a quick recap. What we did last time, we imported a shale gas well data set, went through some tables here, and basically did some distribution plots and defining the font size and adding the labels and X and Y labels and title. And also we did a scatter plot, covered box plot, what these lines in the box plot mean. And also we went through and did some Julian plots. And finally, we covered a violin plot at the end. Just wanted to cover one thing real quick in this scatter plot or in this Julian plot. One thing that you can do actually is under kind, the default is scatter. One thing that is pretty handy in Jupyter Notebook, you can actually hit Shift Tab. If you do hit Shift Tab once, it'll pull up this window, okay? If you hit Shift Tab while you're inside the parentheses 4 times, 1, 2, 3, 4, it would bring up the whole window at the bottom. And you can see here, for example, you can, if you forget what arguments go into these Julian plots, you can always just hit the Shift Tab while inside of the parentheses 1 or 2 or 3 or 4 times, depending on what you're trying to do. And it would bring up this window where you can see more information. So for example, under kind, you can scroll down and let's find kind. Kind, you can always do a Control F here. Here we go, kind. You can feed in scatter, KDE, hist, hexagon, or whatever you're interested in. The default is scatter, but you can, let's just try, for example, a hexagon. So let's try hex instead of scatter. If you try hex, you can see the plot change now, and you can see the points, like for example, these prop and loading wells, much better in this case. So you can go back to scatter or whatever plot you're interested in. This is just one way of defining kind. Just remember, inside of these parentheses, you can always do Shift Tab. If you do it one time, you can always hit the plus sign and it will expand it for you. And even hit this, it would expand it right here. Or you can just hit the Shift Tab 1, 2, 3, 4 times, and it would open up this whole window, and you can actually go over all the arguments that go inside of these this Julian plot. Okay, so with that being said, let's go ahead and let's continue where we left off last time. Let's actually go ahead and create a pair plot. A pair plot is simply a plot of all the parameters versus one another, all in one plot. Now, the only disadvantage of pair plot is that it takes, if you're like plotting all your columns in your data set, in this case, df.columns, let's look at df. If I have so many parameters here, if you do sns.pairplot, it's going to take some time to run this. So you can do pair plot, and let's just say, let's feed in the argument of df, which is my data frame. And also, if you forget, you can always do Shift Tab, and it shows you what arguments you can feed in. Like in this case, we're interested in the scatter plot of all the parameters. And let's just feed in one more thing here. Let's feed in HUE, which basically color codes it by a category. So just recall, if I do a df category here, what you see here, if I just do unique and run this, I have 2 categories in this column. I have new design and I have vintage designs. Okay, So what I can do, I can color code it by new design versus vintage design by defining a parameter called HUE, and then pass in category, which is the name of the column. And if I run this, it's going to take some time. So we're just going to wait until this runs, because with 500 wells and it's plotting all of these parameters versus one another. So it's a lot of plotting in the background. So it's going to take some time. One thing you can always do is you can always drop some columns. For example, you can do df.drop and pass in all the columns that you want to drop. For example, you can just, if you're trying to drop all these, you know, some of these features, you can just copy and paste these and just do, you can do in place is equal to true, which means once it's dropped, it is permanently dropped. It's not temporarily dropped. And then you can also do a access is equal to 1, which means dropping the columns as opposed to rows. Access is equal to 0 means dropping rows, but access is equal to 1 means dropping columns. In this case, I'm not going to drop anything. I'm just showing you that you can do that and just focus on fewer parameters for pair plot. But you can always do a quick df.drop, pass in all the parameters that you want to drop, do in place is equal to true, which means the parameters get permanently dropped. If it's in place is equal to false, it'd be just a temporary drop. And then access is equal to 1. It means dropping all the columns, which is what you're interested in this case. So I'm just going to delete this for now. And this is almost, we're almost at a point where this is going to get plotted. And you're going to see here in a minute. So I'm plotting all the parameters and I'm color coding it by category. Here we go. So you can see here, you have a lot of parameters here. You can see stage spacing, barrels per foot, well spacing, and all the other parameters at the bottom. And it's just a lot. So you can see the scatter plot of each one versus one another. And in the diagonal right here, you can see the distribution plot of these parameters. Okay, see the distribution plot of these parameters. You can always save this image. You know, save image as and just save it on your computer and basically print it as PDF or whatever you want to do with it. But my recommendation is to always just focus on the parameters that you're interested in as opposed to everything for ease of seeing what's going on in your data set. Okay, so that's a pair plot. You can see it's half line of code, we're able to generate this pair plot right here. Okay, so now let's go ahead and talk about LM plot. This is something that we haven't covered yet. LM plot, sns.lm plot. And let's just go ahead and pass in, if I do LM plot, if I do shift tab, you can see here, we got to pass in X, Y, and then data. So what I'm going to do, I'm going to say X is equal to, I'm going to pass in, let's just go up here and let's pass in, for example, lateral length, and then as X, and then let's pass in Y is equal to EUR per 1,000 feet. Okay, and then the data is going to be the DF data frame that we defined. And then let's also use hue again, HUE, and color coded by category. Here we go. So you can see here, new design, which are pretty much anything looks like to be about 8,000 feet and up, are color coded in blue, and the vintage design is color coded in orange. And this is pretty much all your data. You can see all your like lateral length. If you don't want to color code it by this, just to avoid confusion, for example, you can always delete it, rerun again, and here we go. This line here is your linear plot line, and this shaded area represents the 95% confidence interval. Okay, so that's an LM plot. And then I have a pretty detailed description of what LM plot is and how it's calculated in the book. So feel free to check that out. And then let's go ahead and do another LM plot. And this time we're going to use category as the column. So let's go ahead and, for example, copy and paste this here. I'm going to take this, copy and paste it. And what I'm going to do, I'm going to add an argument called column, and I'm going to have the column as category. When you run this, you can see here, you can see a new design and vintage design in two separate plots, as opposed to all in one plot. And where did I get column? You can, if you do Shift Tab, one of the arguments that you can pass in is column, and that's how you can pass in whatever argument you're interested in. You can play around with these. There are height, aspect ratios. You can define the coloring. There are so many things that you can change to your perfection and to your needs. And there's a pretty good, Seaborn has done a very good job highlighting pretty much defining every single parameter and what you can do with it. So feel free to read through this and play around with these parameters. I'm just going through the fundamentals right now, but you can feel free to go through all these. Now let's also do another plot. Let's do a bar plot, which we haven't done yet. So SNS, as you can imagine, dot bar plot, and let's pass in DF, and let's pass in DF of category. Let's do category, and let's also do a bar plot of DF of category versus DF of EUR per 1,000 feet in this case. Okay, and then what I'm going to do is I'm going to pass in the mean estimator is going to be numpy.mean, np.mean, and let's run this, see what it looks like. So it just says to pass in X and Y. So here's X and here's Y. So get rid of that. Here we go. You can see here the new design and the vintage. You see the new design has a slightly higher EUR than the vintage design in this data set. And basically that's what you can use a quick plot of quick use of bar plots. Okay. You can also do a count plot in Seaborn. You can do sns.count plot, and you can pass in DF and just pass in category. These are the categorical column that we have, and we can just pass in X is equal to that. Here we go. We have the count instead of mean in this case. We have the count. And by the way, you can again click on this and go to hit Shift Tab and expand this, and estimator. You have the function, the default I believe is mean, but you can actually define the if you go down here, find the estimator. You can do different types of. You can do standard deviation, mean, median, like whatever you're interested in. Okay. So here's that. Here's the count plot. Let's also do a box plot of the category as well. We went through the box plot, but I wanted to actually go over the box plot of the category. So let's do sns.boxplot again. Here's box plot, and let's pass in DF, and let's pass in category, and let's also do pass in DF of EUR per 1,000 feet. Here we go. And then if I run this, you can see here the new design, the vintage, and you can see the box plot. And you can always pass in a different coloring scheme if you do palette like this. I like the rainbow color myself. So here we go. Let's do rainbow. and it just looks a little bit better. And let's just feed in X and Y so we can get rid of that red notification. Here we go. So you can see new design and vintage. And basically, you can see the median, 25, 75 percentile, and min and max, and the outliers that we discussed last time. Okay. So, so this is basically doing a box plot. Let's also do a swarm plot. We can always do a swarm plot by doing sns.swarm plot, and let's just pass in df of category, and let's pass in df of in this case, let's just do well spacing. Let's do palette is equal to rainbow. And let's run this. You can see the swarm plot is just another way of visualizing the data. And you can actually, let me just pass in X and Y. I always add it later, but this is just a swarm plot. And basically, you can see the distribution of the data in each of the well spacing in this case. Okay, and then let's go ahead and put two plots on top of one another. Let's do a violin plot and a swarm plot on top of one another. So let's do sns.violin plot, and let's do df of category, and let's do df of well spacing, and just going to define X and Y. And let's also say palette is equal to rainbow. And let's copy and paste this, go down. Let's change this to swarm plot, swarm plot. And let's do category versus well spacing again. And let's run this. Here we go. Now you can see the violin plot and the swarm plot on top of one another. So you can see a pretty good two plots side by side on top of one another. If you want different coloring, for example, you can remove this and run this, and you can see the coloring change now. It just went back to the default coloring in Seaborn. Okay. You can also do different plots such as violin and box plot. Let's do the same thing here. Let's copy and paste this and change this from keep the violin, and instead of swarm, let's do a box plot. If you run this, now you can see, if you recall last time I said this dot in the middle represents the median, and this line in the middle in the box plot represents the median as well. So that's why you can see they're pretty much overlaying one another. Okay, and then if you recall, I said where this solid black line stops, that's your 25 percentile, which is where the box plot lines stops. And then this guy here is your 75 percentile. And then this is your where the light black line stops. That's your min, which is Q1 minus 1.5 times your interquartile range. And then this guy here is your max, which is Q3 plus 1.5 times your interquartile range. And you can see how perfectly they lie on one another. And anything outside of these are called your outliers. Hopefully that makes more sense now with what we've done. And you can always just do the violin plot by itself. If that gets too confusing, just run this and you can see here's your new design, here's your vintage design. and kind of understand what's going on in your plot. So with that being said, I just wanted to stop right here. We'll continue on in the next video. Hope you enjoyed this video. If you liked it, please like and share, subscribe to the channel, and leave your comment, and we'll go from there. Thank you so much, and hope this was helpful.